Hello everyone, today in this video we are going to solve some problems on superposition theorem. So we already know superposition theorem is used to find the force on a charge due to multiple charges, and according to superposition theorem, force on a charge due to number of other charges is vector sum of all the forces on it. So this is the final formula. We have solved many questions on superposition theorem on our previous video. If you want to check, the link is given in the description box. So this is the question. Charge of 5 microcoulomb, 10 microcoulomb and minus 10 microcoulomb are placed at the vertices of equilateral triangle of side 5 centimeter in air. Calculate the force on 5 microcoulomb. So this is an equilateral triangle with side 5 centimeter and 3 charges are placed. So I want to find the force on 5 microcoulomb, so I'm keeping 5 microcoulomb at the top so that making the diagram becomes easy. Now this is positive, this is positive, so this 10 microcoulomb will try to repel this 5 microcoulomb, so the force will be in upward direction like this. So force on A due to B, so I'm giving name ABC, and this minus 10 microcoulomb will try to attract because they are unlike charges, so the force will be in downward direction, so this will attract this 5 microcoulomb. So force on A due to C will be in downward direction. Now we have got two forces and the angle between them is 120 degree because this straight line is 180 degree and this is 60 degree because this triangle is equilateral triangle, so this angle is 180 minus 60, that is 120. So if we find the resultant of this two, we'll get the resultant force on charge A. So using triangle law we can find this. So let's see. So this is the diagram. So given QA is given, that is 5 microcoulomb, that is positive, and QB is 10 microcoulomb positive and QC is minus 10 microcoulomb. So I'm not writing negative out here because using the Coulomb's law we find magnitude only, not the direction, so I'm not putting this negative out here. So all the lengths are given, that is 5 centimeter, and centi means 10 to the power minus 2 and micro means 10 to the power minus 6. So force on A due to B is given by K, QA, QB by distance between them. So if you put the value of K is 9 into 10 to the power 9, and these are the value of charges and this is the distance. So now we will multiply the numbers together and will add and subtract the power of 10. Now I'll take this minus 4 up. Now we'll get 180 Newton, and the direction is along BA. It is going from B to A, so this direction is along BA. Similarly, we can find the force on A due to C. Now if you see, the charges are equal, distances are equal as previous one, so only the direction will be different. So I'll not do all the calculation again, so I can directly write 180 Newton because the value of charges and distance are same as our previous calculation. So 180 Newton, only direction will be different, that is along AC, so it is going from A towards C. So our FAB was along BA. So now we'll do the vector addition of these two forces. So using superposition theorem, force on charge A will be FAB plus FAC, addition of these two charges in the form of vector. So this is vector addition and the angle between them is 120 degree. Now we'll use triangle law and the resultant. Now I'm writing without cap, you can see. Now this is the resultant, not the vector. So this is the formula we already know. Cos 120 is minus half, so this 2 and this 2 get cancelled and this minus will come in front. So now this is 2 180 square minus 180 square, so this is 180 square, so you cancel this square and root, so this is 180 Newton towards the right from A. So by symmetry, because these two vectors are equal, so the resultant will be in the direction at 60 degree from one of the vectors. So by symmetry we can say it is going towards the right from this point A. So the total force is 180 Newton. So this is all the answer done together. So you can pause the video and copy. So this is the second page, I guess. So now this is the same kind of question. You can try it. 5 microcoulomb, 10 microcoulomb and minus 10 microcoulomb are placed at the vertices of equilateral triangle of side 1 millimeter in air. Calculate the force on 10 microcoulomb, and distance is millimeter. So in our previous case it was centimeter, but now it is millimeter. And when you make the triangle, keep the charge minus 10 microcoulomb at the top. So now next question, consider 3 charges q1, q2, q3 each equal to q at the vertices of an equilateral triangle of side L. What is the force on the charge capital Q placed at the centroid of the triangle? So we have an equilateral triangle of side L, and we are keeping q1, q2, q3, and this point is the centroid where all the perpendicular from each side meet. That is the centroid. So I'm keeping Q at the centroid. Now we are considering all the charges to be positive. So this and these are positive. So this Q3 will try to repel this in this direction. So force on O due to C will be in this direction. Similarly, force on this Q due to this Q will be in this direction, and force on this due to this will be in downward direction. Now we have got 3 forces. Now first we will add these 2 forces using vector addition, and we will get the resultant in this direction. Now we have another one which is in this direction, and we will find the resultant of this 2, and resultant of this 2 will be our final force. So this is the diagram. You can pause and copy. So drawing the diagram is most important part of this question. So please understand how to draw the diagram properly. So QA, QB, QC is equal, so I am writing it to be Q, and the distances OA, OB, OC are equal, and I am considering it to be R. So now force on Q due to A is given by K QA and capital Q divided by OA square. So if you put the values, so QA, QB, QC is Q, and this charge out here is capital Q, K divided by R square. So I'm considering this to be F. So KQQ by R square is F, and this force is along AO. It is going from A towards O, so the direction is AO. Similarly, force on O due to B is given by this expression. Now if you put the values, you will get same as this. See, KQQ by R square, out here also KQQ by R square. So this is equal to F. So out here FOB is also equal to F, and this is along BO. So this is going in this direction. And similarly, force on O due to C is given by this expression, and if you put the values, you will get the same value because all the charges and distances are similar for all 3 cases. So this is also F. Now this is the diagram. Now we'll first find the resultant of FOB and FOC. So angle between them is 120 degree. So if you put the values, and this 2 will get cancelled, and you are left with F. Now this F is in the direction OA. It is going upward, starting from O going towards A. So by symmetry, because these 2 are equal vector at angle 120 degree, so resultant will be at 60 degree from one of the vector, so it will go straight upward. So now we have to find the resultant of FBC and FOA, because this 2 is giving FBC. Now we are left with this vector and the vector going downward, that is FOA. Now we'll find the resultant of this 2. Now FBC is equal to F, and which is going upward, and FOA is also equal to F, and it is going downward. So we have to find the resultant of FBC and FOA. But you can see they are equal vector, having magnitude F and they are going in opposite direction, so their difference will be 0 because they will cancel each other as they are equal and opposite. So I am writing the resultant of FOA and FBC is 0 because they are equal. We already know magnitude is F and they are opposite. One is going along O to A, another is going along A to O. So OA and AO, so equal and opposite, so the total force on Q is 0. So this is all the answer done together. So you can pause the video and copy. So this is first page and this is second page, and this is the next question. 4 point charges each plus 16 microcoulomb are placed at the corner of a square of side 0.2 meter. Calculate the force on one of the charge. So this is a square and the side is 0.2 meter. Now we have to find the force on one of the charge. So let the charge be this. So due to this charge at D, the force will be repulsive because all the charges are positive, so the force will be in this direction, and the distance between them is 0.2 meter. So you can easily find this force using Coulomb's law. Now next is this charge will also repel this charge in this direction, and the distance between them can be found out using Pythagoras theorem in this triangle. So it will be root 2 into 0.2 meter. So you can easily find this force as well. And the third force, which is in upward direction, because this B will try to repel this A, so it will be in this direction. So this is the diagram. So now first we'll find the resultant of this this force and this force. So this will be in this direction, and then we'll find the resultant of this rate force and this force. So the final force will be the resultant of this vector and this vector. So please try this question, and if you can't solve, you can check the link for the solution video in the description box, and answer for this will be 110.3 Newton and the force is along CA. So it will go like this. So this is the next question. 3 point charges plus 2 microcoulomb minus 3 microcoulomb and minus 3 microcoulomb are kept at vertices of an equilateral triangle of side 30 cm. What should be the sign and the magnitude of the charge small q to be placed at the midpoint of side BC so that the charge at A remains in equilibrium? So let's see. We have 3 point charges at the vertices of a triangle, equilateral triangle of side 20 cm, and we have to find what charge should we place out here in the midpoint of BC so that this 2 microcoulomb remains in equilibrium without moving. Let's see the solution. So now this minus 3 microcoulomb will try to pull this towards it, so the force will be in downward direction. So I'm just writing FB, and similarly this minus 3 microcoulomb will try to pull this positive charge, so let the force be FC. So the forces are downward. Now you can see we can find the resultant of these two forces. So angle between them is 60 degree because triangle is equilateral triangle, so the resultant force will be in downward direction. So I'm writing the name FBC for this force. Now we have to place one charge out here Q so that this 2 microcoulomb do not move downward. So as there is already force on this 2 microcoulomb that is downward, so we should give upward force. So we should give FQ in upward direction. So this Q should be positive so that it repel, because due to this 3 microcoulomb it will try to come down. So we have to send it upward using a positive charge. So this is the diagram. QA, QB and QC are given. So I am not writing minus out here, I am writing negative and positive, and all the distances are 20 centimeter, AB, AC and BC. So FB, this force FB will be given by this. So if you put the values, you will get, so out here micro means 10 to the power minus 6 and centi means 10 to the power minus 2. So you will get 1.35 Newton along AB, so it is coming in this direction. So out here you can see FB is 1.35 Newton, that is going downward. Now if you see this force, the charges are similar, -3 -3 +2 and distance is equal, so this force and this force has to be equal. So I can write FC is equal to 1.35 Newton because distances and pair of charges is same for FB and FC. Now we will find the resultant of FB and FC. The resultant vector will be given by this, and if you put the value, cos 60 is half, so this 2 and this 2 get cancelled, so you are left with 2 1.35 square plus 1.35 square, so it will be √3 1.35 square, so this square and this will cancel, so we are left with √3, so this will be the total force and the direction will be along AQ, so it will come down. So in order to keep this charge stationary, I have to keep positive charge at rest out here, so and the force FQ and FBC must be equal and opposite, so these two forces must be equal. So now this FQ will be QA capital Q by AQ square, so this distance square is equal to FBC, we already know the value. Now this, if you put this Q this side, you will get this. Now we need to find this AQ square, so in order to find AQ we can make use of Pythagoras theorem. So out here you can see AQ square is equal to AC square minus QC square. So now if you put the values, you will get AQ square to be 3 into 10 to the power minus 2. So we will not find AQ because in our equation we need AQ square, so we will directly put AQ square out here. Now after putting all the values, and QA was already given, that is 2 microcoulomb, so if you put the values, you will get Q to be 3.8 into 10 to the power minus 6 coulomb. So minus 6 means microcoulomb, so as Q repel plus 2 microcoulomb, polarity of Q must be positive, because in order to repel this plus 2 it should be positive. So if you put positive 3.8 microcoulomb out here, this charge will not come down. So now this is all the answer done in one page. You can pause the video and copy. So this is the next part, I guess. So I think this is the end of the video. I would love to hear your opinion about my video, so please write something in the comment section. Please don't forget to like the video. Yeah, you can like it now, and please subscribe my channel if you are new to this channel, and you can share it to your friends. And out here I'm giving my phone number. If you need help in any topic, you can WhatsApp me. Thank you.